Hi there, welcome to my channel. In today's video, we are going to solve this medium lead code problem. Problem number 36, valid Sudoku. Let's understand the problem first. They are saying, determine there is a 9 by 9 Sudoku board. Now we have to validate if that particular 9 by 9 Sudoku board is a valid one or not. To validate that, we have three rules. Now, if you see, they are saying only the filled cells needs to be validated. It means we do not need to worry about the cells that are not filled yet. For example, if you see here, there are some cells which are empty. So we will not worry about them. We will only focus on the cells which are already filled. To validate if a particular Sudoku board is a valid one or not, we have three rules. Let's understand the rules now. Okay, the first rule says each row must contain the digits 1 to 9 without repetition. So in this particular Sudoku, these are called the rows. These are the rows. This is the row 1, row 2, row 3, like that. So in each row, we have to make sure that no digit is repeated twice. Now, if you see in the row 1, there's 5, 3, 7. So this is a valid row. In the next row, we have 6, 1, 9, 5. This again is a valid row. In the next one, we have 9, 8, 6. This again is a valid row. Likewise, we have to validate this. So assume what if we had a 6 here also at this place. If we had 6, then in this row, this is not a valid row because now 6 is coming here twice. Let's check the rule number 2 now. So rule number 2 says each column must contain the digits 1 to 9 without repetition. So these are called the columns. These are the columns of this Sudoku board. We have to validate the same thing what we did for the rows column wise now. So if we see in the first column, we have 5, 6, 8, 4, 7. So nothing is repeated. So it's a valid column. 3 and 9, this again is a valid column. Likewise, we have to check the others. Now assume if there was a 3 here. In this column, we have 3 twice. So this column is not a valid Sudoku column. Let's go to the rule number 3 now. Now it's saying that each of the 9 3 by 3 boxes. So this is the one box, this is box number 2, this is box number 3. Like we have 4, 5, 6, 7, 8, 9. All these boxes individually must also have only the unique numbers from 1 to 9. Now if you check the box 1, we have 5, 3, 6, 9, 8. This is a valid box. 91795, this again. So these are the valid box. So what if we had a 7 here? And now if you see in this particular square, we have 7 twice. So this is not a valid square, 3 by 3 square for this Sudoku board. Okay, so we just saw in what cases a Sudoku board will not be valid. So whenever one of these three conditions is not met, either a row is having a digit which is repeated, or a column is having duplicate digit, or any of the 3 by 3 boxes having a duplicate digit, then it will not be a valid Sudoku. Let's see further. A Sudoku board partially filled could be valid but is not necessarily solvable. It's the same thing what I was telling here, that only the filled cells needs to be validated. We will not try to solve this. If putting in a new value is making it invalid, we need not to consider that. The next note is only the filled cells needs to be validated according to the mentioned rules. The same thing. Or we have these examples. We have a digit wherever a value is there, and for the empty cells, a dot is used here. So for example, we have this one input, it is saying true. This is the example 2. Now in this case, it is coming as false. So it is saying in this square, if we say the first square, we have 8 twice. One 8 is here, the other is here. So for that reason, it is an invalid Sudoku box. The constraints are its length will always be 9, and each row will also have length only 9. That is, there will be only 9 columns, and every element in the board will be between 1 to 9 only if it has a value, and if it is an empty, then it will be denoted with a dot. We have understood the problem. Now let's try to find out the approach. We have to do three things. One, to validate column wise, other is to validate row wise, and then to validate 3 by 3 square wise. The best thing we can use is a set where we will keep adding the values. For example, for the first row, we will keep adding the values 5, 3, 7, and if a 3 is again found here in the first row, then we will be able to find out it with the help of set that we are adding a duplicate entry. When we are solving row wise, we will have 9 sets, 1 2 3, like that for 9 rows, and we will keep adding the values for each row, and whenever a duplicate is found, we will return false. The same will be done the column wise and then square wise. For square wise, 3 by 3 square will be considered as one set. This will be the second set. This will be the third set. Now all the entries from this square needs to be added to a single set. Now we need to find out how will we determine that this is, for example, if we convert this into 3 by 3 square, say this is the row 0, row 1, row 2, and then column 0, column 1, column 2. So now this complete 9 by 9 square is converted into 3 by 3 square. In that case, now we can add the values from this 3 by square into the hash set that belongs to 0 to 0. 0 comma 0, and this can be added to 0 comma 1, this can be added to 0 comma 2, likewise. Now how will we figure it out? For that, what we can do is, if we see there are 9 rows here, so if we divide it by 3, we will be able to convert these 9 by 9 square into individual 3 by 3 square. For example, if we see here, the coordinates of this particular cell are 0 comma 9. Now if we divide 0 comma 9 by 3, then we will get 0 comma 3, and we know this cell is 0 comma 3 as per the new hash set. So we will divide all the rows and columns, all the coordinates of rows and columns with 3, and then we will add the values to their respective sets when we are validating it square wise. Let's try to code this solution now. We will focus on the columns first, and then we will use the same code for rows and squares, 3 by 3 squares. So for columns, I'm going to use the default dictionary. We can use the normal dictionary also, but why default dictionary is used? Because in case of default dictionary, there will always be some default value given to a pair of key value pair, even when key is not, that particular key is not defined yet. So it will not give us the key not found error. But in case of normal dictionary, key not found will be there. So we need to handle that. But in case of default dictionary, we will need not to do that. So I will use collections dot default dict. Collection here is a package of Python, and default dict is it's one of the method. So I'm going to have values as set by default. Now we will traverse through this complete board. So for R in range 0 to 9, because we have 9 rows, and for columns in again range 0 to 9, again we have 9 columns. We need to validate this only if there is some value, and not in case of if there is a dot there. So we will run our validation only if it is not a dot. So if board RC is not equals to a dot, in that case we will run our validation. If board, this particular element which we are traversing right now, is in calls for C, if it is there, then we will return false, because in that case it's a duplicate element. But what if it's not there? If it's not there, in that case we will add this. So we will do calls dot add board R and C. Here we will have C. For C we are adding this. This is done for the columns. Now, but if we have not returned false here, in that case we have already executed the entire loop, but we have not found any duplicates in the columns. In that case, we can return true. Let's add rows and squares also here. So for rows, again we will use this, and for squares, 3 by 3 squares, we are again having a default dictionary. Now here with this OR, we will also check if is in row R, or if this is in the box. So for that, we will add box R comma C. In that case, we will return false, and if it is not found, then we will add it to rows and boxes also. So rows R dot add this, and box. Okay, we did one mistake here. We have to divide it by 3, like we discussed earlier. Now to add this also, we will divide it by 3, r by 3, comma c by 3, and then dot add. I think this is pretty much this. Let's try to run this. This is executed fine. Let's submit this. I found the issue. I have not used the floor division here. It is answering in a float type, so I will use that. Now let's try to submit this. This is submitted successfully after I use this double division method, which is floors the output of division. We can see this is already accepted. Let's talk about its time and space complexity. In this case, we are defining a column, row, and box dictionary. So in each case, we are having the space it's taking n 9 space for the case, and then 9 for its values also, because each column can have 9 further entries. So in short, it will be 81 here. Same will be applicable for, this is the time space comp. The same will be applicable for the rows and these box. Now if we see, we have not defined any other variable. So in short, total space complexity will be order of 81 plus 81 plus 81, which we can say is a linear order space. Now let's talk about the time complexity, how much time it will take to perform the operation. Now for each row, there are 9 rows, and for 9 rows, there are 9 columns. It will be 9 into 9. So total time complexity is again order of 81, which we can say is order of n, as this is a linear time complexity. But this is the worst case. If our method is able to return this false before executing the complete loops, it will be reduced. That's all about this problem. If you have any better solutions for this, please let me know in the comment section, and visit my channel for more such videos. Thank you so much.